Thank you very much, everyone. And today I'm going to be giving a bit of forensic analysis to some of the proposed depositional environments for the Ediacaran biota in Mistaken Point. I only wish that I had actually provided the same level of scrutiny to my own title and abstract submission, so apologies for the glaring spelling error there. Colleagues who have spoken before in this session have already given a really good introduction to the rangeomorphs. Mistaken Point is known to contain some of the largest architecturally complex multicellular organisms in the world, and I'm not going to go over the rangeomorphs and those kinds of groups because the speakers before me and indeed the last speaker in the session will do that better than I ever could anyway. So just to give you a bit of locality information, we're on the southern coast of the Avalon Peninsula of Newfoundland in Canada, and the Mistaken Point Ecological Reserve here, shown in red, was designated a few decades ago to protect these very important fossils and was earlier this year inscribed as a UNESCO World Heritage Site. And within the reserve, there's roughly a 2-kilometre siliciclastic sequence going from the Druck Formation up to the Famuse Formation. And this has been widely interpreted by the vast majority of authors to represent deep marine settings. However, there is one contradiction to this, and this has been put forward in 3 papers in recent years by Greg Rettelak, proposing that in fact these deposits represent terrestrial and shallow marine environments, and this has been used to support the previous hypothesis that in fact the Ediacaran fauna were lichens. So what I'm going to do is go through some of the arguments that have been provided for this terrestrial and shallow marine setting, discuss those, and then also, as we get to the end, discuss some other features that either are or are not there. Now, there have been a number of geochemical proxies that have been used to support the terrestrial or paleosol hypothesis for Mistaken Point, and all of those have been based on data first presented by Canfield and others in 2007. So I thought that's a good place to start, just to look at some of the data. Here again, we have the stratigraphy running from oldest on the left to youngest on the right. Within the Mistaken Point Ecological Reserve, we only have the section from the Druck to the Formuse, but below that in the general region, we also have the Mull Bay Formation and the Gasquier's diamictite, which is interpreted to be a glacial deposit. And with the carbon data from Canfield, that was interpreted to show a general trend increasing up through the Famuse Formation, and was interpreted by Canfield and others to show at the oldest section an oligotrophic deep marine succession going up to delta front environments with the increasing amount of carbon representing the increased sedimentation rate. And likewise with the sulfur isotopes, these were interpreted to be reflective the initial increase in fractionation through the Gasquier's and the Druck to reflect increasing melting and the increasing sulfate to the oceans that would represent, with the decreasing fractionation later on in the section to represent either a return to normal sulfate levels or an increase in sedimentation rate in line with what we would expect from a delta front environment. One of the data set that Canfield presented was iron speciation data. This is the ratio between highly reactive iron and total iron. And this was taken by Greg Rettelak in 2013 and represented. One thing to notice that the scale bar is the other way up in the upper part of this diagram, and that data which were previously presented as across the whole formation have been condensed into these thin slivers. Now, this data was presented using exactly the same data, but presented on these fields, presenting that some of the formations were heavily paleosols. However, these fields were in the paper referenced to come from a paper by Ku et al. In 2008. This was a small regional study from a tropical carbonate setting. And in fact, these fields that are proposed have no bearing at all to those shown in Ku. In fact, there is their offshore field, there is their bedrock field, and what is not presented is in fact, which is shown in the Ku data, is that the global deep marine average for the modern day covers all of those, and indeed every point that is within the proposed paleosol field is indeed within one standard deviation of the Cambrian marine average given by Poulton. So moving on to carbon and sulfur ratios, Canfield presented essentially the raw data for organic carbon and sulfur. And this was used again on fields to show that in a number of the formations there was a strong freshwater signal, and this was again used to support the terrestrial and paleosol hypothesis for the biota that were within these formations. The fields on this diagram are based on a methodology shown in Rasewell and Berner 1986, which is itself based on a methodology in Berner and Rasewell 1984. And what's important to notice here is that the abstract of that original methodology paper clearly states that the methodology does not apply to rocks which have less than 1% carbon. And if we go back to the diagram from Canfield, we can see that the highest value in the entire sequence is at 0.7. Indeed, there are many areas where the weight percent of carbon is 0, such as in the lower mistaken point, and the average for the entire sequence is 0.05%, and therefore again this use of this chemical proxy is well outside the methodology that was originally erected. Another methodology and a proxy that's been used is that of the chemical index of weathering. This is a calculation to classify and calculate the extent of weathering experienced by a soil. And what you can do with that is you can then take it to work out the mean annual paleotemperature of your paleosol. And in the papers mentioned, this was used to say that the mistaken point formation, where the most prominent fossil surfaces are found, was deposited in paleosols around 11 degrees C. This itself is based on a methodology given by Oskarsson et al. 2012, which is completely based on studies in Iceland on soils from the last 5,500 years. And the technique clearly states in that paper that it may only be used on volcanic soils in Iceland or regions with basaltic soils and a similar climate to Iceland, with no independent evidence that these rocks are indeed paleosols or rocks with a lithology based on basaltic rock. This methodology can obviously not be applied to the rocks at mistaken point. Again, the chemical index of weathering was also used to propose that there was a mean annual precipitation rate for the mistaken point so-called paleosols of around 1 meter per year. This is based on a methodology given in Sheldon et al. In 2002, where they compared modern American soils with nearby weather data from weather stations to back calculate how chemical index of weathering was related to precipitation rate. Again, this is modern studies. If both the mean annual paleotemperature and mean annual precipitation fail to it's failed to be provided how 500 million years worth of lithification, metamorphosis, erosion and weathering can be accounted in these, and so I would propose that the use of these techniques on Ediacaran rocks should not be used until those factors can be accounted for when the original methodologies are proposing that they only be used on modern rocks. So, while initially compelling, these geochemical proxies have been used either well outside their original usage, and I'd use the legal term ultra vires, which means beyond the powers. The carbon and sulfur ratios and the CIW data is clearly beyond the powers of the original methodology, or indeed that the iron speciation data is just not diagnostic. It could reflect terrestrial deposits, but equally we've shown that it could represent deep marine deposits. So now I want to go on to some of the physical sedimentary structures. First, starting with hummocky cross stratification. It was mentioned that hummocky cross stratification was found at the mistaken point formation in the reserve. This was based on a citation of a non-peer-reviewed abstract talk given by Dalrymple et al. In 1999, and failed to recognise that all the authors on that talk later went on to present with wood a very good paper looking at the sedimentology of the reserve, where they all agree that this is a deep marine deposit, and in fact those structures which had previously been mentioned in one talk as hummocky cross stratification were indeed tectonic ripples, as we've seen on some of the talks previously. Pipe structures. One pipe structure was imaged in the 2014 paper and was proposed to be a gas escape structure from a terrestrial pyroclastic flow. Extensive search of this ash deposit by myself and others, we have not been able to find any other examples of this structure, and I would simply say, knowing the mineralogy of this deposit, that this is simply a secondary growth of chlorite. And so I would say that pipe structures are indeed not present within these deposits. It's also been said that intraformational clasts are incompatible with the deep water setting for mistaken point. That was mentioned in the 2014 paper, which of course goes against the wide literature, and if you don't like papers by Stowe for any particular reason, there's all of those ones as well, which quote interformational claystone clasts in deep marine settings as well. So again, that's not diagnostic of a terrestrial or shallow marine environment. Graded beds. It's been said that siltstone beds in Newfoundland do not grade upwards into shale or downwards into sandstone. Now, if we go and look in the reserve, we have these wonderful laterally extensive turbidite beds. And if we go and we slab some of these, on the next few slides I'm going to show, the left hand is the true colour slabbed section, and on the right hand side I've altered the colours to really bring out the features in the rock. This is a section from under the fossiliferous D surface that lies roughly 2 meters below the E surface, and here we can see clear grading, turbidite, Baumer, B up into cross-bedded C, then parallel laminated D and E. Again, we can see the same on the left-hand side. This is a slab from under the fossiliferous famous E surface. Again, and one of the things I would point out is the sharp lithological contacts between the various deposits, which is completely at odds with the gradational boundaries we would expect to see with paleosols. On the right-hand side, this is a classic Stowe sequence from a high-density turbidite seen from the Briscoe Formation in the reserve. Yep, and we also see slump sections. Here's Tom Hearing for scale here, and this ash here that's slabbed has been used as a décollement surface for this slump. So I would also say that carbonate concretions have been proposed as representing terrestrial environments, and we know that carbonate concretions are found in many different environments. Volcanic bombs have been proposed. These aren't actually up from Mistaken Point, but the ones that have been shown from the Bonavista Peninsula represent here a crack and here some carbonate concretions. And bed colour has already been proposed, and new mapping that we have shown where we found the E surface over 8 kilometres away from the original Mistaken Point horizon shows that the transition from red to green is actually not stratigraphic, as it crosses from being above the E surface to being below the E surface, and therefore can't be used as diagnostic. I would end by saying that, in conclusion, on the deposition and environment, the organic carbon data is compatible with deep marine environments, and we have a complete lack of subaerial exposure within the section. If you go above the section to above where the frondose organisms are found, we find these beautiful desiccation cracks. This is about a kilometre above the highest frondose organism, and we're seeing these beautiful desiccation cracks with folded back parts of the microbial mat. So I would say, on the balance of probabilities, this is a deep marine sequence, and the shallow marine and terrestrial proposal has been entertained for, unfortunately, far too long. I would simply say, why does this matter in a paleontological conference? Because these are all the taxonomic affinities that have been proposed for the Ediacaran biota. If I take off the ones that aren't found in Newfoundland, these are the ones that are left. And if we accept that this is a deep marine environment and therefore lightly aphotic, we can strip out the plants, the lichens and the biconts, and we are left with a number of taxonomic affinities, which I'm sure my more paleontologically inclined colleagues will comment on more. I would end by saying thank you to all these lovely people, and we're running a lovely conference next year. We'd love to see you all there.